Now that your students have completed the activity on KP Index, it's important that they understand that that is not the only value or measure of data that is going to be able to evidence the existence of a solar or geomagnetic storm. So we're going to actually go into some other data collections. One is from the GOES satellites and its X-ray flux measurements, as well as we go down and look at sunspot data to determine significantly active solar events. So in this particular activity, we're going to merge this understanding of the measures of solar activity with the importance of corroborating data sets together in order to prove that a certain event and the qualitative data of the types of occurrences that are happening as a result of that geomagnetic event are actually from a solar storm. So in layman's terms, here's what we're going to be looking at. Students are going to be given scenarios, and as you can see here, there's a description of each scenario and what was observed during that time. You'll notice highlighted here that there is an event that occurred on July 23rd, 2013, where power outages were seen in the Cleveland, Ohio area and in Florida. And so how can we make sure that we don't group this in as a solar event that the students may think is in alignment with the causes of the other events that are a part of this table. And the way we're going to do that is through an activity where they're going to learn about triangulating data sets. So in the student activity book, you will notice that this July 23rd date is not going to be highlighted. They're going to have this list of about 5 events that are possible solar events and the qualitative data that was associated with them, going from 1989 all the way up to 2015. You'll also notice that they have been given 3 values. One is a daily KP index chart. Another is the daily X-ray flux background that they just finished reading about earlier on. And the third is the daily sunspot values, also what they just finished reading about in the background material. So if they visit each of these locations, all right, they will be able to see. So for example, on March 13th, 1989, they can actually go and visit the ISWA site, and this is actually going to take them out so that they can investigate some of that solar data on their own. And you see here's the max KP values. Down here in the bottom left, you're going to help perhaps to guide them to change those dates to match. So in this particular case, they would need to take a look at that March 13th, 1989 date to see what the activity looked like at that time. What I will tell you is that you will want to show them that they don't have to pull the drop down and manually go in. They actually can very easily go in, and I believe that was March the 13th, 1989. So we'll go ahead to March the 13th, 1989. And when we do that, what you will see after clicking apply is that over time, there we have March 13th. If we advance ahead a day, you can see the max KP value becomes extreme that entire day of March 13th. So they already will now know that based upon KP value, this was a pretty active day. But we're not finished. Let's make sure that we actually here on Earth saw those things through other corroborating evidence. So for that same date, March 13th, 1989, we're going to go out to an actual Danish site. And when we go to this Danish site, this is the data that's going to be from the GOES satellite. I always like to choose a date that's a day or two before. So we know we're looking for March, again, the 13th. So we're going to set it up for March the 12th, and we're going to watch that from March the 12th until, again, going back to 1989, we're going to go that to about March the 14th. And if we begin seeing the same type of evidence, there it is, March the 13th. We're seeing that we're up in this red area denoted as the X value. And if you recall from the reading that the students did, these are all base 10, which is, by the way, a great math activity. If you have more advanced students in the math area, you can talk about base 10 mathematics when you're talking about the A, B, C, D, X, or M and X. So There we go. We have two sets of corroborating evidence showing that this was indeed a highly active solar day. So let's go ahead and we're going to take a look at one more chart. And this is actually a chart of spreadsheet data where we're seeing the sunspot values as they over time, and the source data is there as well. You can see the original data files if you want to take students back to show authentic sources. But if we scroll down through this data to get to 1989, what we'll see is that in March, again, the 13th of 1989, relative to the other events, you see that we can certainly see where there's some more active times over the duration here. But as we go to 1989 and we go to 313, you can see that we're in much higher levels, 162, 181. Certainly this was a peak time period of sunspot activity that we would have expected during that time. So here's what that means. That means this event where major power failures occurred, leaving 6 million citizens without electricity, there is definitely enough evidence given the KP, the X-rays, and the sunspots to attribute this to a solar event. What they are going to do is the exact same thing for July, April, July, and March of these years. And what they will find is that when they get to the July 23rd event, they will not see that there is any activity actually that was seen here on Earth. Now actually this was a major solar event that occurred, but it was a miss. It actually did not, the coronal mass ejection didn't actually hit the Earth. So you could do an extension activity here and ask the students to do two things really. You could ask them to actually determine why power outages were seen in Cleveland and Florida. Well, I'll tell you, what you will find as they go through and look at perhaps National Weather Service data or NOAA data is that there were significant terrestrial weather storms, thunderstorms that caused power outages in both of these areas. That was the reason, nothing solar. But you could also have them do some research about the July 23rd event to show why it didn't have an impact here because of the fact that it was a near miss. So when you think about the activity, there's two primary goals here that you would want your students to achieve. One, you want them to understand the different metrics that can be used to analyze the strength, the relative strength of the solar activity and the geomagnetic storms that could potentially result from that solar activity. That's the first, and we specifically chose the KP value, the X-ray flux background value, and the sunspot values to be able to do that. But the second thing is having students build that understanding that simply because one of these values is being used to be able to determine the strength, it's always good to be able to corroborate that with other evidence that can strengthen your position as you're making your claims, and you're supporting that evidence with actual data to be able to make your draw your conclusions, and then develop trends and pattern analyses like we've been talking about in earlier chapters of this activity book based upon that.